Hi, welcome to a product review by Robojax. In this video we are going to do the review of these two modules, YX801 and YX850 battery protection power off modules. This is a module that can connect and disconnect your DC from the battery when there is DC or external power, and when the power is disconnected it will connect your battery. As you saw, there is a small interruption, but generally it can connect automatically your power. So we have power, battery, and your load. We cannot call this uninterrupted power supply or UPS because there is a relay and there is 0.7 second delay when it is connected. So it can connect your device. And X850 also can be used with a charger, so you can connect your charger and charge your battery while there is power. When the power goes off, the battery will be connected. This has a lot of application and it will be very useful for a lot of projects. We have 5 volts version and 12 volts version. It can work up to load of 48 volts. Let's get started with this, which connects the battery. You can get the data sheet and related files and links from robojax.com. The link is below the video in the description. The first module is YX-X804 and the operating voltage is 12 to 48 volts for this, and relay is 12 volts, so that's why the minimum voltage is 12 volts for the load. So this is your load operating voltage, and the maximum load is 10 ampere because the relay can handle up to 10 ampere. Then you do your math to calculate the power based on your voltage. And can this be used with a charger? No. And there is other model which has this diode, and YX-X850, the operating voltage is 5 to 48 volts because the relay is 5 volts, so you can use it up to 5 volts, from 5 volts up to 48 volts. And the maximum load is again 10 ampere. And X850 can be used with a charger because of this 10 ampere diode that is there. I'm going to explain it fully. Both modules uses this XL7005 converter. When you connect 48 volts up to 48 volts, this will convert it to 5 volts for the relay and pass the voltage out to your load. So your load voltage will not change and this will not alter. It's just a switch to turn on and off and connect your load and battery. So here is a module, the YX-X801. And this module does not have a diode, it's directly connected. You can use only a power supply. The power supply is coming from AC and it produces DC. The voltage for your load, which is connected in here, is the same as your power supply, and the voltage is the same as your battery. So these two must match, so you can supply the power here. This is a 12 volts version, and so you cannot use anything less than 12 volts, but you can use up to 48 volts. If your load is 20 volts, 24 volts, 40 volts, 48 volts, anything between 12 to 48, it will work. And we have here a regulator that converts whatever voltage you have to 12 volts to power this up, but the actual voltage will come to your device. And when the power is disconnected, the battery will kick in and you will get a voltage from battery. So here is how it operates. Now, when we have AC power, the AC is connected, and this is the relay I've just shown you like that. So the negative from green is connected to the battery, and negative comes and goes to your load. But the positive is connected to this contact inside this relay. So inside that relay, the load is connected to AC. You see, it's not connected to the DC. So your load is being powered up. As soon as the power gets off, the relay will turn off, it will be connected in here. So AC is now off. In this case, on DC, this contact is down now. Now the AC is not connected, and the power comes from DC and powers up. There is a delay from this relay of 0.7 second. So that's very important to know. This is not uninterrupted. This is interrupted with 0.7 seconds. So keep that in mind. And here in the model X850 version has a diode. Now you have a charger in this case. This is not a power supply, but a charger, which can charge or set your battery, and the charge voltage and a battery voltage and your AC load is the same. It must be the same, otherwise it will not work. Now let me show you how it works. When the AC power is available, the power will come here. The negative is connected the same way. The positive comes here and it powers up your load through this contact of the relay. And in the meantime, this diode is working. The contact doesn't change, but from the diode, the energy comes and charges your battery. So this is charging. Because it goes through this diode, there is 0.78 volts drop, which means whatever voltage for this you said, you have to add 0.78 to it, because the voltage does not reach fully here. So we have 0.78 volts and the battery will be charged. Now when the power goes off, now this relay contact is going down with a delay of 0.7 seconds, and the battery is supplying now via this line to your load. So this way this module works. And here on the actual module, the negative is connected for this side. This is for your power supply, and the positive on this side. And for your battery, the same way, it says battery. You see battery plus and minus. This minus and this minus is connected. If you look at the back, you see this is connected all together. And it is coming even for the output, which is this terminal. So negative is all connected from here. It comes, and the relay will just turn on and off. And we have an LED which will tell you the state of the power, AC power. And this is a converter, a buck converter, that if the voltage is higher than 12 volts, let's say if it is 15, 24 volts, 18 volts, or 36, even 48 volts, it will regulate it and makes it 12 volts for their device. And it does not change anything, the input voltage. Whatever is the input voltage, it will come. Now this module is exactly the same. They've just moved these components on this side and have added a 10 ampere diode. So this cannot handle more than 10 ampere. The load that you are connecting is 10 ampere, which means you have to know the power of your module, or divide power by voltage, and you will get the current. You're asking about my power supply. This is a constant current power supply that supplies the voltage. So you cannot use just any DC power supply. It must be a charger that is rated for your battery, and the voltage of your load must be the same, otherwise it will not work. Let me show you the test. I've connected 12 volts bulbs. Because I want to test it with higher voltage, I put these bulbs in series. So this is connected in series. So regardless, these two act as my load, and they have been connected in here. This will not charge your battery. This is just a switch. This does not alter the voltage or current or anything. It just disconnects and connects them. Right now, you can see this is now connected. The lights are on. Let me show you this voltage. And here now you can read the input power supply voltage, 12.65 volts. And the light is on. This light means that AC power is coming here. And the bulbs or the load is on, powering up via power supply, which is supplied from AC. Now I'm disconnecting the power supply, so you can see that this LED will turn off, and this will blink, because this switch will just blink and turn it on for you. So now there is no external power. The LED is off, but these are now powering up. Now I'm measuring the current from my power supply 411 milliampere. So whatever is the load plus this relay. Now let's measure the current for the load only. And here this is 375 milliampere. The load current. Let me disconnect the power supply and we will see the current from the battery. $390 milliampere, because the voltage is higher a little for the battery at the moment. Now let me increase the input voltage so we can see that the relay is working. Even when it reaches up to 24 volts, I can increase, because these two in series can get up to 24. So I'm increasing the voltage, as you can see, 14, 15. So if I turn the, as you can see, the lights are getting brighter. So 24 volts, I'm not going higher than that. The module is perfectly working. The power is disconnected, the battery will be connected, but because my battery is now 12.8 volts, it will be 12.8 volts. You see? And now let's just disconnect the power. As you heard, there was a click and connected. When the power comes, you see very little difference, but when it disconnects, now I've connected the load to the module. Now this module that has diode, that's 850. Now I'm measuring the current from the power supply. It shows 989, and we know this needs at least 350 milliampere. The rest is charging the battery. Now this is the battery charge current. From AC, it's charging the battery and powering up my bulbs, as you can see. So let me disconnect the AC power so you can see that the current will change the polarity to negative, and it will be reduced for the power, for the load. So now I've disconnected it. It shows 401 milliampere. So this 401 milliampere is going to the bulb, and relay is also off. Connect my power supply back again. Now the current is going back in the other direction. It become positive now. Thank you for watching. This was the review of these two modules that connect and disconnect your power with the battery interrupted, not uninterrupted. Please thumb up the video and also share and subscribe. I really appreciate it. Your hand.